Hi there, and welcome to another fabulous Math 130 lecture on video with your instructor, me, Professor Mimi Rasky. We're going to finish up looking at matrices using 2D arrays in Java today, and we're going to do this by an example finding the trace of a matrix using 2D arrays. So if you look in your lecture notes, we first are going to go over some definitions here. There's a few special matrices out there that we may use on occasion. And if you take linear algebra, you'll find out a lot more of them. The first special matrix is called the square matrix. And a square matrix is any matrix whose size or dimension is n by n. In other words, it has the same number of rows as it does columns. And also, in a square matrix, the diagonal that starts in the upper left and ends in the lower right is called the main diagonal. So what's this got to do with anything? Well, when you're trying to find the trace of a square matrix, the trace is defined to be the sum of all the diagonal elements. So let's take a look at the two nice square matrices we have in our lecture notes and find the trace by hand, not too hard, a little bit of arithmetic, and then we'll write our method. So if you look at this first 3 by 3 matrix here, the main diagonal consists of the elements here along that main diagonal, and we're going to add those together to get the trace. And in mathematics, the trace notation is TR parentheses the name of your matrix. So here we're going to go 3 plus -2 plus 2, which is equal to 3. And that's the answer, and that's the trace for that first matrix. How about this other matrix? A little bit bigger here. It's 4 by 4, and the main diagonal here consists of those elements. So if we sum those up, 1 plus 1 plus 0 plus -2, we get 0. Is that possible? Sure. That was the sum, so there's the trace of that matrix. Now, to write a method that we're going to call find trace, the method header is going to start with public static, and since it's going to return a sum, and typically we probably should do double, so let's do that, even though we're having integer examples there. And the name of our method is find trace, and it only has one thing in the parameter list, a square matrix, right? So int and then a pair of brackets here, and we'll name this local variable array, get it? Curly brace to start the body of the method. We're going to declare and initialize the sum variable to be 0, and this is going to capture those elements along the main diagonal on a running total. I'm going to put a little bit of logic in here to check to see if the parameter is indeed a square matrix before we actually find the sum. So how do we check to see if it's square or not? We want those rows and columns to be the same number of each. So if the number of rows, which is in this length field, array.length, is not equal to, exclamation point equals sign, the number of columns, array bracket bracket 0.length, then it's not a square matrix and there really is no such thing as a trace. But how about if we'll return some ridiculous number that will be kind of out of range? How about if we return, I don't know, -1 million without the comma there? Java doesn't like you to put commas. And that will sort of just be a little flag or indicator that there's really no trace for this one. Now we could do an if-else, but if we're at this point, if the return actually was executed, it would be out of the method. So we actually don't need to put an else. I'm going to start my nested for loop right now. So for, how about int I equals 0, I less than number of rows, which is array.length, I plus plus, and then the inner for loop, so we'll control that with the index j for j equals 0, j less than, and you know I could use array.length again because square matrices are supposed to have the same number of rows as columns, and then inside this nested for loop, I want to add only the elements along the main diagonal. I don't want to just add anybody. So let's take a look here. That's going to require a little bit of logic. If we look at this example we did up here, this first element in this matrix B is at the 0th row, 0th column. Okay. The next element along the main diagonal is in row 1, column 1, okay? The next element that we had to add was in row 2, column 2, okay, and then the last element we had there was in row 3, column 3. So you notice a pattern here. When the row was the same as the column, we added that in. So that's going to be our logic here. We're going to check with a little if statement if the row number, so if I equal j, add that element in. So we'll go sum plus equals array bracket bracket I bracket bracket j. And we're not done because remember we have to return something here. And boy, I screwed up, didn't I? Why do I say that? Because I really, if I'm going to return a double here, I should have just declared this a double and this one a double too, huh? Well, sometimes you find this stuff out after you do it. So let's change it. In my other examples, I had integer arrays. So if I was just changing it up for this time, so we're going to have double there. And so we'll go through the array, get the trace, and then we'll return it by returning the sum. And there's the end of our method. Voila! Does it work? Well, if we go over to NetVeeds and find it, let's see, array trace, and I did get some code written here, although I did use ints instead of doubles, but you can easily change it. Here in this public class array trace, and I have some nice matrices that I've already initialized, a couple of 2x2s and a 3x3 and a 4x2. And the very last line in this main is system.out.println, the trace of the matrix is, and then I do the method call inside of the println, find trace, and then I send it one of the matrices. So I'm sending it D matrix. How about if I send it C matrix? If you look up here, my C matrix is a 3x3, so it is square. In fact, that one is the same one in your lecture notes. And then after main, we have our method header and the method body, and it's almost the same as what we did by hand, except I did ints instead of doubles. So if we run this, doing a method call on that 3x3 matrix, what happens? Ah, look, the trace of the matrix is 3, which is exactly what we calculated. Now, just for fun, I wanted to do a method call where instead of sending it that matrix that's square, what if we send it that 4x2 matrix, which technically doesn't even have a trace? It's meaningless. If we run the code here, let's see. We get the trace of the matrix is -1 million, and that was our little indicator that it's not really a legit square matrix. And so that's it for finding the trace of a matrix. Happy programming.